Hey everyone, in this lecture, we're going to cover hypothesis testing, and this is really the foundation for statistical tests. But I'll admit the concept of hypothesis testing can seem a little lofty, a little abstract, kind of complicated. I remember learning this in stats class back when I was in undergrad, and I remember being very confused. So, my goal here is to explain the concept the way that I really wish someone had explained it to me in the first place, in the way that's practical and that's going to help you when we move on to actually conducting our statistical tests in the coming weeks, and also in a way that's concise but effective. So I'm going to do this by breaking down 4 steps of hypothesis testing. Before we get into that, just a quick note on the difference between descriptive versus inferential statistics. So far in this class, the statistics we've done have been descriptive. Descriptive statistics are used to summarize, organize, and simplify data. So examples of this are the mean, median, mode, range, etc. And so we've already covered these. These types of statistics are definitely important because, as the name suggests, they help us to describe the data. Today, we'll be moving on to what's called inferential statistics, the statistics that helps us to make inferences, also known as hypothesis testing. So this is the type of statistics we need to test how data measure up to our hypotheses. Hypothesis testing in statistics is a way to test the results of your survey or of your experiment to see if the results are meaningful. In stats language, we use the word significant. If your results are significant, you have a significant effect or a significant difference. You're basically trying to figure out what are the odds that your results may have happened by chance. We use statistics to represent the real world. In the real world, things can happen by chance. For example, let's say you take a certain medication or a certain treatment. There is a possibility that you could get better just by chance, that there's no actual effect of the treatment. So if it's likely that your results might have happened by chance, then that's not a significant finding. If there is a very small likelihood, and by the way, most of the time we use a criteria of 5%. So for example, if there's less than a 5%, a very small likelihood that your results just happened by chance, then you can say that your result is significant. And that's the gist of hypothesis testing. There's 3 types of inferential statistical tests that we'll be learning in this class. Those are chi-square, correlation, which is R, and T for t-tests. So as I mentioned, I'll be presenting this concept step by step. There's 4 general steps for hypothesis testing. For step 1, you'll need to state your hypothesis. After all, we are doing hypothesis testing, so you need to know what you're testing your data up against. You'll state the null hypothesis and the alternative hypothesis, and I'll explain that in a little bit. Step 2 is you're going to set a criteria, which we usually refer to this as a critical value or alpha, and there's different ways to do this depending on the type of statistical test you're running. So whether it's chi-square or correlation or t-test, you can usually find the critical value on a corresponding chart. You just have to know how to use the chart, and we'll learn that in this class. Step 3 is you're going to collect your data and compute your sample statistics. So based on your data, you'll usually be using a formula to calculate the sample statistic. In this class, again, you'll be learning how to compute the chi-square statistic, the R statistic, which is for correlation, and the T statistic for t-tests. And then lastly, step 4, you'll compare your sample statistic that you computed in step 3. You'll compare that to the critical value that you found from step 2, and based on that comparison, you'll make a decision about whether or not your results are significant. All right, so step 1, remember the goal is to state the hypotheses. You're going to lay out 2. The null hypothesis, which is denoted by this H sub 0, H with a subscript of 0. The null hypothesis is that there is no effect. There's no change, no difference, no relationship. You're basically saying nothing happened. And then the alternative hypothesis is the opposite. The alternative hypothesis is the contender. So this is that there is an effect, there is a change, there is a difference, or there's a relationship between whatever variables you're studying. And so that's denoted as H sub 1, or some people use H sub A for alternative. So with hypothesis testing, we're testing the null hypothesis. We're actually testing the null hypothesis. With each test, we'll be trying to figure out what is the probability that there's no effect. What is the probability that the null hypothesis is true? And we want for that probability to be really small. Usually we want it to be less than 5%. In other words, we want there to be a very small likelihood, a less than 5% chance that the null hypothesis is true. Because think about it, that leaves us with at least 95% confidence that our alternative hypothesis is true, or that there is an effect. So let's take a quick look at this example. Dr. Charlie is comparing the protein consumption of men and women. He suspects that on average, women consume more protein than men. So basically, this researcher is comparing how much protein people eat, women versus men. So you can pause now to see if you can come up with a null hypothesis and an alternative hypothesis. The null hypothesis, remember, is that nothing is going on. So in this case, the null hypothesis would be that there is no difference in the amount of protein that women and men consume. In other words, women and men consume the same amount of protein. There's no difference. So I'll look back at the scenario to find the alternative hypothesis. Dr. Charlie suspects that women consume more protein than men. So this is his suspicion. That's his hypothesis. The alternative hypothesis is that there is a difference between these two populations. Specifically, according to Dr. Charlie, he hypothesizes that women consume more protein than men. That's the null hypothesis and the alternative hypothesis. So let's try another one. Dr. Penny is interested in the ability of drug X to treat OCD. So the null hypothesis, again, is that there's no effect. Drug X has no effect on OCD symptoms. And then the alternative hypothesis is that there is an effect. So I might say that drug X reduces OCD symptoms. I could also say that the alternative hypothesis is that drug X increases OCD symptoms. Both of those delineate that there is an effect. So it just depends on the researcher's theory and what they think is going to happen. Okay, our next step, step 2, is to set a criteria. We need to set a threshold by which we will judge our results. We often refer to this as a critical value. The critical value is represented by alpha. That Greek letter A, that lowercase symbol, is called alpha, and that's our significance level. It's basically your probability threshold. It's the value that you set to define at which point your result is very unlikely. Remember, you want your result to be unlikely to be happening by chance. So again, we usually set this a value at 0.05 or 5%. It's again an indication of probability, so it's usually represented by P. So P equals 0.05 means that our criteria is that we want our data to be 5%, less than 5% chance happening by chance. Sometimes if researchers want to set a stricter criteria, they might set their P or their alpha level at 0.01 or 1%. So anyway, alpha is our critical value. That's our threshold. Any values beyond that alpha level are our critical region. So you want your result to be within the critical region. So if your critical value or your alpha is 0.05, you want your results to be beyond that range. Here is a visual. This is a normal distribution of means of the null hypothesis. So let's say we set our criteria to fall here. This is our alpha level. With those vertical lines are our alpha level. And so the area beyond that is our critical region. So if the data that we collect is within this critical region, or it's in an area of low probability, we have more confidence that there is a real effect. The null hypothesis is not likely to be true. If I get a value that is beyond my critical value, then I know that my results are significant. Step 3 is going to be to collect your data and compute the statistics. So in this class, you'll usually be giving a set of data and then a formula to use based on which statistical test we're working on, chi-square, correlation, or t-test. So you're going to compute that statistic based on the data that you have and based on the appropriate formula. And then lastly, step 4 is to make a decision. In order to do that, you're going to compare the result, the statistic that you computed in step 3. You're going to compare that to the criteria or the critical value that you found in step 2. And based on that comparison, you're going to have 2 options. You can either reject the null or retain the null hypothesis. So let's talk about what that means. When you reject the null, you're saying that you're confident that your results were not due to chance. In other words, you have a real effect, there's a true difference, or there's a real relationship, depending on what your study is about. So you can accept your alternative hypothesis. You can conclude that your results are statistically significant because the probability of getting that result is less than 5% if it were just due to chance. So rejecting the null is a good thing, despite how it might sound. On the flip side, when you retain the null or fail to reject, which is kind of a weird way of saying it, that means that you're saying that the results likely happened by chance, and therefore you're not confident enough to reject the null. You're basically accepting the null hypothesis, which, remember, the null hypothesis is that there's no actual effect or no statistically significant difference. So yeah, this is just going to take some time to practice and memorize to get this down. I don't know who came up with this type of wording, but I understand how confusing it might sound. Usually when we talk about rejection, it's a bad thing. Nobody wants to be rejected. But in statistics, rejection is good. Rejecting the null hypothesis means that your results are statistically significant, that it did not happen by chance. But wait, there's more. So there's always room for error in the real world. Statistics isn't always perfect, and sometimes, we make mistakes. It's not always a perfect representation. So there's 2 important types of errors. Type 1 error is also known as a false positive. This is when the researcher rejects the null hypothesis, even though that null hypothesis is true. So, for example, a researcher might conclude that a treatment does have a statistically significant effect, but in reality, the treatment does not actually work. There's no effect of the treatment. Type 2 error is also known as a miss. You've missed the effect. So this is when a researcher retains the null hypothesis, but the null hypothesis is actually false. So, for example, let's say the treatment actually does work in reality. In real life, the treatment works, but the researcher has failed to detect the treatment effect in their statistical analysis. So I think this picture is really helpful, and you can refer back to it to help you remember the difference between type 1 and type 2 error. Okay, so here's some practice that I'm going to walk us through. Dr. Posey is interested in the effect of preschool attendance on cooperation during early childhood. He decides to compare cooperation scores of children who attend preschool to those who don't. All right, so first question is state the null hypothesis and the alternative hypothesis. And so you can go ahead and press pause and try to figure that out. All right, so the null hypothesis is that attending preschool has no effect on cooperation. Remember, the null hypothesis is that nothing's happening. The alternative hypothesis is that attending preschool has an effect on cooperation. And you can be more specific by saying attending preschool increases cooperation or decreases if that's the hypothesis. So the alternative hypothesis is that there is an effect. All right, before conducting his statistical test, Dr. Posey set an alpha level of P equals 0.05. So that's his criteria. Dr. Posey finds that the mean cooperation score of preschool children is slightly higher than the non-preschool children and finds an alpha level of P equals 0.07. So the question here is, should Dr. Posey reject or retain the null hypothesis? All right. In this scenario, Dr. Posey should retain the null hypothesis. The result is not statistically significant. Remember, his criteria was 0.05, and you want the result to be less than that. So his result was 0.07, so it doesn't meet the criteria. I put this here to demonstrate that sometimes you can have an effect or result, but it might not be statistically significant. In this example, the preschool kids had better cooperation scores, but the result was not statistically significant. So in your real world application, if you are reading headlines or some news story or research, that's a really important factor to consider. Sometimes people might announce results or an effect, but in reality, it's not statistically significant. So something to keep in mind. And that brings us to workshop number 7. The first part of it is hypothesis testing. Remember that even if you aren't going to submit this workshop for credit, you should still pause the video and attempt to answer these questions. And that'll be it for this video. The chi-square lecture is going to be posted in a separate video recording. All right, everyone, take care.